your assignment. Okay, so we're going through problem number 31 on section 5.6 to make sure we have one problem that I know I've had a captured audience for you to make sure you know how to do this, because I know some of you haven't had a chance to watch the other videos yet. You should still do that, especially the first and second one. You could maybe get by without watching the third video because of this problem, but I still recommend the third video. Okay. Find the complex zeros right in factored form. So find the complex zeros. Now when it says complex, that doesn't mean it has to be imaginary. That means they can be real or imaginary, right? And then the last step we're doing is writing our answer in factored form. Okay, does anyone recognize this problem and how we would factor this to begin with? Nope, because there's no x right here. Can't just factor out an x if there's no x in this part to factor out.
X plus 2 and x squared minus 1.
Are you really not recognizing this?
No.
This is called a difference of cubes. This is called a difference of cubes. A difference of cubes can be factored using the pattern x minus 1, because this is x cubed and this is 1 cubed. And then x squared plus x plus 1, I think. Did I do that right? So that this, so it's like you've got x cubed minus a positive 1 cubed. And then you use the little pattern that we've learned previously. So this is going to be a minus b, and then a squared plus ab plus b squared, right? Okay, so that gives us one of our factors right there. So what 0 goes with that factor? Yeah, so we don't even have to use synthetic division on this problem because we were able to find that factor by factoring. Okay, now this one is a prime factor. Because it's prime, that means it's not factorable. Okay? So we know we can't factor it, so when we know something won't factor, what do we have to use? Quadratic formula. Since it won't factor, it also does us no good to try and use synthetic division or our rational roots theorem, because the only rational root is this one. So the only way to solve this is using quadratic formula. So let's go for it. So x equals negative b plus or minus square root, I'm just going to write it down, b squared minus 4ac all over 2a. So negative b is, we're just looking at this piece right here, so negative 1, right? Plus or minus the square root of b squared, so that would be a 1 squared, minus 4 times a times c, well a is 1 and c is 1. And then all over 2 times a, well, a is 1. Okay. So now let's go ahead and simplify this. So that gives us negative 1 plus or minus the square root of 1 minus 4. Negative 3. At this point previously we would have said we can't solve this, no solutions. But we're in section 5.6, which means we're finding the complex zeros, which includes the imaginary ones. So we go ahead and simplify this imaginary answer. Negative 1 plus or minus square root of 3, which we can't simplify, times I to get rid of the negative 1. The I is not in the root. In fact, you might typically write the I in the front of the square root of 3, so that you don't confuse it with not being in the root. Okay, so how many more zeros is that? That's 2 more zeros. So we already found the 0 that's x equals 1, And now we found two more zeros, negative plus or minus I squared root 3 over 2 and negative 1 minus I squared root 2. I don't know what I said. Anyway, you've got two answers here because of the plus minus. Your book officially actually writes this like this instead. I squared root 3 over 2. Why have they written it that way and what have they done? Yeah, they separated out the fraction, and I think the reason they do it that way is then you've got the real part and the imaginary part. Real part, imaginary part, and they're kind of separate, right? Okay, so our 3 zeros, I'm fine with you leaving it like this though. So here's 2 of the zeros, here's the third zero. The entire thing is degree 3, so there are exactly 3 zeros.
I thought you said when you square root a negative, it'd be 3i. Why is it I square root instead of just 3i?
The square root of 3 is just the square root of 3. If this had been a 9, then the square root of 9 would have been 3i. Or if it was a square root of 4, then we would have had 2i. But when it's something like 3 where we can't take the square root, we have to leave the number in the square root.
You mean negative 4? So negative 4.
If it was the square root of negative 4, then the answer would be plus or minus 2i. Yeah. Okay, the last part of this question says to write our answer in factored form. That means we're going to take this entire thing and write it factored. So we have the factor x minus 1, because one of our zeros is 1. And we have the factor x minus and negative 1 plus I squared root 3 over 2. So I'm going to change that to x plus 1 minus I squared root 3 over 2. There's one factor. And then our third factor would be no, it would still be a plus here because this is still a minus, right? So if you subtract that negative, you get a plus there. But what changes? Yeah, now we're doing subtracting the minus 1, which gives us the plus I squared root 3 over 2. So there it is in factored form. So if I wanted to, I could FOIL this all back out again and get my original problem back. Which actually there are problems that ask you to do that, but not this one. Okay, both of them are x plus because our answer here is a minus in the front here. So you have to do, remember how if the 0 is a positive 1, then the factor is an x minus 1. If the 0 is a negative, then the factor has a positive. So since this has a negative in the front of it, both of these are positive. The only thing that switches is these two signs right here.